Okay, in chapter 10, we're going to look at inputting data and issues that we might encounter. And we're also going to take a broad look at Excel data analysts, just a real high level view. So before we do our analysis, we arrange the data we get from our survey into a tabular format. Each row pertains to the answers provided by a single respondent. Every column represents a question on the questionnaire. Data entry refers to the creation of a computer file that holds the raw data taken from all of the acceptable completed questionnaires. Data coding is defined as the identification of code values that are associated with the possible responses for each question. For example, in the advanced auto, we've got 0 as a code for males and 1 as a code for females. There's also, along with every survey, a data code book, and it's going to give us information about the survey, the questions on the survey, the variable names associated with those questions, and code numbers and their associated values associated with each variable. So we also are going to have codes that are used when an item is missing, so that it's evident to everybody who will be using the survey that we didn't get an answer on that particular question. Now, we're going to get a variety of different type of errors, and one of the categories of errors is known as non-sampling errors. And these are errors in the research process pertaining to anything except the sample size. And we went over sample size errors last time. So we have one category of non-sampling errors is field worker errors. And we have intentional field worker errors where the interviewer deliberately falsifies his or her work. And you do that, for example, by cheating through submitting bogus completed questionnaires. There's also unintentional field worker errors. And this is where the interviewer makes mistakes, such as those caused by fatigue or lack of understanding of how to administer the questions. The best way to minimize field worker errors is to hire a reputable data collection company that has excellent training, good supervision, and built-in validation techniques to ensure that field workers will be very unlikely to commit errors. There's also non-sampling errors that are caused by respondent errors. So intentional respondent errors are those committed when respondents knowingly provide false answers. Tactics such as incentives, assuring anonymity, providing confidentiality, or follow-up validation are used to reduce the level of intentional respondent error. Unintentional respondent error occurs when the respondent is confused, distracted, or otherwise inattentive. So some of the tactics that can minimize unintentional respondent errors are good questionnaire design, adequate pre-testing of the questionnaire, adding no opinion or unsure response options, and prompters such as, do you have any other things that come to mind? And these will help minimize the amount of unintentional respondent error in a survey. So there's types of non-response errors, and non-response is defined as the failure of a prospective respondent to answer specific questions on the questionnaire. This is a respondent error, and it can be either intentional or unintentional. This is a big problem. Non-response has been labeled as the marketing research industry's biggest problem. Industry observers believe that the major problems leading to non-response are caused by fears of invasion of privacy, skepticism of consumers regarding the benefits of participating in research, and the use of research as a disguise for telemarketing. So some of the types of non-response errors: refusal to participate in a survey, break-offs during the interview, or refusals to answer specific questions or omitting certain items. So again, there's three types of non-response errors: refusal, break-off, and item omission. And we see here examples of each one of those. So how do we reduce refusal to participate? Well, we can make an offer to call back at a more convenient time. We can identify the name of the research company and client so that the respondent knows it's legitimate. Making the interviews as short as possible, and emphasizing again that the interviewer is not selling anything. So the researcher has to examine the responses for data quality problems before they begin analyzing the data. And the things we want to look for in the raw data inspection, we want to look for incomplete responses, non-responses to specific questions, item omissions, and yay or nay saying patterns. And this is when one respondent answers most of the question yes or strongly agree, or no and strongly disagree. And it implies that the answers are not all valid. Other things to look for: middle of the road patterns. And that's where you have a preponderance of no opinion responses. Respondent may have checked more than one response option. Sometimes respondents fail to look at the back of the questionnaire page and missed all the questions on the back. The respondent may have ignored an agree-disagree scale and simply written in their own personal comments. So how do we handle data quality issues when we discover them? Well, if the errors are egregious, it's most likely that we'll throw out the entire data row. In other words, all of that respondent's answers to the questions. If the errors are minor, then we might leave in the respondent's row and perhaps change some to indicate blank or missing data rather than allow the erroneous data in there. So what is an acceptable respondent? At what point does an incomplete or problem respondent constitute an acceptable respondent that the researcher will allow into data analysis? Well, the researcher must have a definition or otherwise they must specify the criteria for an acceptable respondent. In other words, how many errors are going to be allowed and still make the respondent acceptable, their answers acceptable. Most research studies consist of questions focused on the primary purpose of the study, while some of the questions are of a lesser or secondary nature. An acceptable respondent may be defined as one who answered all of the primary questions satisfactorily. Now we have in Excel for Windows a tool called Excel Data Analyst. So why use Excel? Well, everyone is acquainted with Excel, and the tool that we have produces tables that can be copied and pasted into word processor applications without extensive reformatting for professional appearance. And also, we avoid the cost of expensive alternatives to Excel. So there's two parts, and we discussed these Monday when we went over Excel, but let's take a look at them again. I'll bring up our worksheet and do a share over here. So we have a data worksheet where we've captured all of the answers for each one of the respondents. And again, the rows indicate all the respondents, and there's 1,000 of those. The columns are questions. And again, we've got 50 questions, and each column then represents every single respondent's answer to that question. Obviously, in the first row, we've got the names of the variables, and they are somewhat descriptive, but not as much as we would like. So we have a code book, and that's in the Define Variables worksheet. So here, we've got the names of variables, such as town size, a description, size of the town or city the respondent is in, code values, what are the legitimate code values that town size can take on, and what each one of those code values represents. Okay, let's go back to data. And again, in data, we have variables. Each variable occupies a separate column. Variable labels are a unique descriptive word in row 1 of each variable column. Respondents, rows of numbers in each, in the various cells of the columns, of course, not including row 1, which is the descriptive row. And the data set is the matrix of rows and columns. Then in the code book, Define Variables, variable labels are in row 1, variable descriptions. These are things you can also type in or paste a long description if you want to change the values. Value codes are the related code values for each variable's possible answer, the variable label, and they're placed in row 3, as we see here. And then those are the value codes, and then the value labels for each of the variables' value codes are placed below them in row 4. So in other words, a value code of 1 has a label of under 10K. So the Define Variables worksheet is the data code book because it identifies the column label, provides a long description of the variable, lists the answer value code numbers and matches the answer value labels to those value codes. There's several data sets that you can look at. They're available on www.xldataanalyst.com. We're using the advanced automotive concepts, but there's also Friendly's Market and a new restaurant server, a survey. And each of these are laid out in the similar pattern that we've just been discussing. Okay, let's go back here. One thing we want to make sure of is we enable the macro content. So that'll be something you'll do the first time you open it up. And after that, it should retain the setting. We have our case study for the semester project, Advanced Automotives, in Sakai Resources and then Advanced Automotive. So in addition, we can filter data if we want to, and then unfilter it so we can get back to our original data set. This is a standard Excel operation. I don't think we need to do that in our class, but obviously this is an Excel worksheet, so you can use the standard options like sorting, standard functions like sorting and filtering, unduplicating, and so on. So these are all standard Excel functions. And finally, we can use Excel functions like sum, count, standard deviation, average, and so on. And we will be making use of those in, not on the Windows side, but on the Mac side. Remember, there's two different ways that we'll be doing this. There's a Mac method, and then there's a Windows method. So in the Mac method, we're going to be using more fundamental Excel functions. Okay, any questions on that? All right.